Hi guys, this is Dr. Hayek again, and today we will talk about the conformation of acyclic alkanes. It's important to know that conformations are different arrangements of atoms that are interconverted by rotation about single bonds. What do we mean by this is that a rotation is allowed around a sigma bond between two carbons, as you can see it in here. So the rotation, where we have the red labeled atom pointing up, now after rotation is going to be pointing down. Now we can give names for these two different conformations. We can say that this conformation, we call it eclipsed, and this conformation we call it staggered. Now you can notice that in the eclipsed conformation, the CH bonds on one carbon are directly aligned with the CH bonds on the second carbon. However, in the staggered conformation, the CH bond on one carbon bisects the CH bond angle on the adjacent carbon. Now probably you can see it better in this conformation here, where if we are looking straight on one of the carbons, okay, so we can see that the dihedral angle between the two CH bonds on the two adjacent carbons is around 0 degree. However, for the staggered conformation, the dihedral angle between two CH bonds is 60 degrees. Now, how can we draw this if we were to draw it on a paper? Now, Newman, who is a scientist, he came up with a way of drawing eclipsed and staggered conformation. So now we will talk about Newman projection. So it's called projection because it's like projecting a 3D structure to a 2D plane. So Newman said that for a back carbon, we can just draw a circle. And for the front carbon, we can just designate it by a dot in the middle of the circle. So now the circle represents the back carbon and the dot represents the front carbon. Now for the bonds, we can simply draw the bonds as follows. So from the front carbon you can draw 3 bonds, 1, 2, and 3. Now if we were to draw the staggered conformation on the back carbon, we start from the circle. So we have 60 degree dihedral angle between each two bonds. So this would be the staggered. So this is the staggered conformation. Now drawing the eclipsed conformation, you can simply draw a circle, a dot in the middle of the circle. Then in a similar way, we can draw the bonds on the front carbon. And then for the bonds on the back carbon, we can simply draw 3 bonds with a dihedral angle of 0 degree. This is going to be the eclipsed conformation. Now it's important to mention that staggered is more stable than eclipsed, and this is due to the fact that electron-electron repulsion between bonds in the eclipsed conformation increases its energy compared with the staggered conformation, where the bond electrons are farther apart. And this type of strain is called torsional strain.